What did you come up with for a number for that? For x, x is roughly what? 1.165. Any agreement with that? You agree with that? Anybody else agree? Good. Okay. You can always check it, right? Put it in there, times it by 5, and then do 3 to the power of that. See if it's 600. What? That's wrong when you check it? Let's check here. Come on. 3 to the power of, bracket, 5 times 1.165. I mean, if I took more accuracy, we can, that's probably true, right? Because it's probably 164 or something or other, but. All right, you can look back at that and figure out if there's one little thing that you did. The strategy here, remember, is it's an exponential equation, means the variable's in the exponent. If you're going to solve it, the strategy is use logs to get at the exponent to make it big. Use logs. Take log of both sides to, we'll use this technical term here, get at the exponent or the variable. Then isolate it. Now it's going to be the same even when the variable's on both sides, but the problem is going to be it's going to be more complicated to isolate it. It's still going to be the same thing that you use logs to kind of get at it and get it out of the exponent. So we're going to do one other question together, and then you're going to try the rest of the things in here and gain some confidence from that. Can I move this down here? So we're going to try this question right here. 5 to the 2x equals 8 to the x plus 3. We could be here quite a while trying numbers to see if we get an answer. When the x is in two places, it's harder to do it by trial and error. Grade 8s always discover this when grade 8s come to you and you try to convince them, solving 3x equals 15. You're trying to teach them, look, we have to write our steps down like this because later on it's going to be difficult if you don't learn to write your steps down. You remember being a grade 8 and you said, I don't need your steps. I can see that it's 5. I don't need to do all those steps. And I say, well, what about this? 3x plus 2 equals 11. I still don't need your steps. I can see what it is. I just take off 2 and divide by 3. But then as soon as you give them one where x is in two places, you say, how about this? Smart person. Try that. You can't do it as easily. This you can kind of just work backwards in your mind. This you can't, right? It's the same thing here. As soon as we have x in more than one place, it's more difficult to do it just by trial and error. But the strategy that we used up above is going to work just the same. How does it differ? First of all, these are unrelated, right? 5 and 8 are not powers of the same number. And x is on both sides here, right? Unrelated. Bases. And how does it differ from the exponential equation? The first two problems here, variable in both sides, on both sides. If you're gonna solve this, you're gonna need several of our rules or our laws here. We're going to start by doing exactly the same thing as we did before. If the exponents are there, you want to use logarithms to kind of get at them. If we do the logarithm of both sides, log of that side should be equal to log of this side. If they're equal, then their logarithms are equal. Once you change it to that, what can I do here? Log of 5 to the 2x. What's the logarithm? One of the logarithm laws say about this? This is going to be a rule you use a lot. What can I do with that? Put in front, right? So we got 2x times log of 5, which you just write like that. The same over here, except I'm going to need to do it with brackets, right? Because it's got two terms. So I got to write it like that, x plus 3 times log of 8. This is maybe where it looks different, but now you've reduced it to a linear equation. Other than there's these weird numbers here, you've reduced it to an equation that all you have to do is gather all the x terms on one side and work from there. If this were grade 8 or grade 9, and these were just normal numbers, as you might say, If you had 2 times x times some other weird number and you had this bracket with a number in front, you would do this, right? You'd expand that. That's exactly what you do here. So you're going to have x times log of 8 plus 3 times log of 8. I don't want to work out what these are yet because it's going to turn into a mess, but you could change all these logarithms into approximate decimals and kind of put down long decimals for that and isolate it, just like you would have done in grade 8. There's nothing wrong with that other than it kind of looks ugly after a while. You can try that if you want. You can try that after. Maybe we should try that right now. No, let's not bother. Some people, that's their strategy, is they don't sort of know, they don't remember how to collect the x terms on one side, but then they just change these logs to decimals and then do it like it was grade 9 again. That's essentially what we're doing, but we're leaving it like this. This term has to go on the other side. It's an x term. This term is just a constant term, so it's going to stay over here. All right, so I'm going to change this to 2x log 5 minus x log 8 equals 3 log 8. All right, so I just moved this term over to here. Now I'm going to have to go up here. Okay, so what do I have? I have 2x log 5 minus x log 8 equals that. This is where lots of people get stuck, because now it has to, we don't know what we have to do here. I'm going to rewrite it. 2x log 5, just so we can clearly see what we're going to do. X log 8 equals 3 log 8. You may already know what you might do here. If this were a grade 9 equation, because I want you to parallel it to what you already know. If this said something like, I mean, this is just a number times x. It's two numbers times x, but it's something times x. If you had 7x take away, and here's another number times x. If you had 7x take away 4x equals some number on the other side, 20, what would you do here? Yeah, you'd combine them and you'd write this as 3, right? 3x. That's because this number and this number are really easy to do the subtraction in your head. If you couldn't do 7 minus 4 in your head and you didn't have a calculator, you could write this 3 as whatever 7 minus 4 is, could you not? You could just write 7 minus 4 times x, instead of actually writing it as 3. That's what we're going to have to do here, because we can't do 2 times log 5 minus log 8 in our head, probably. And I don't want to change it to funny decimals and have a big mess here. If I showed this to grade 9s or grade 10s, what would they say we did from here to here? What change did we do there? They wouldn't say all that stuff that I just said about forgetting how to subtract 4 from 7. What would they say? 7x minus 4x, if you write it as x times 7 minus 4, what did we do there with the x? Starts with F, one of your math F words. You factored it out, right? This is factored out. It's got, if you have an x in both terms here, you can factor it out like that. So down below here, if you have this x in both terms, there's an x, you're going to write it out in front of a bracket here. So you're going to factor out the x, and you're going to write down what you have left. Because what you have left is going to be all numbers that we can work with here. 2 log 5 minus log 8 equals 3 log 8. Okay, you're factoring out the x, because now you went from having x in 2 places to x in 1 place, which is what we want, right? Because now we can isolate it. What do I do as the last step to isolate it here? I got x times a big weird number in brackets. What do? This is just a number, right? Because it's just a big expression that has all numbers in it. It's some decimal number the calculator knows. So x times some number is another number. How do I get x by itself? Yeah, you just divide, right? So I'm dividing both sides by that big ugly thing. So it's going to be x is 3 log 8 over that big ugly expression. If you can put that in your calculator properly, you'll have the answer. Can you do that right now, please? Can you make sure you're okay with that and then work on the rest of the questions in there?